Gabala with us. Today's session will be last for around 30 minutes, including a brief Q&A at the end of the session. Please hold your question until Marcin finishes his presentation. Without further ado, let's welcome Marcin.
All right. Hi, everyone. My name is Marcin Gambala, and the title of my talk is GraphQL in Python. I hereby agree to abide by the Pycon APAC Code of Conduct and consent to being recorded and streamed. All right, so we're going to talk about GraphQL in Python. It's actually, I think, a second talk about GraphQL at this conference. Yesterday was talk about Strawberry. I saw this. This will be about two different libraries. So let's start. My name is Marcin, and I come from Poland. I also gave a talk yesterday about database replication, but this is like the main one since I've been using GraphQL for like 6 years now, and I'm really excited about GraphQL. I work as a web developer for the last 10 years. I've been using Python and Django mostly. And I'm working at a startup from Poland, Sailor Commerce, and we built e-commerce platform basically. So it's something like Shopify, but it's entirely open source. So you can check it on GitHub. It's a large code base written in Python and Django if you are interested. Also, it has GraphQL API on top, built with Graphene. So it's also a nice example of large GraphQL code base. So let's start with some theory. What is GraphQL? So GraphQL is a query language used to build APIs, basically. So it's an alternative to REST, which I think most people know, and GraphQL, maybe it's not that popular, although it's been around for like, I don't know, 10 years maybe. It was created by Facebook initially, and they use it for their mobile applications. And now it's open sourced. It's managed by GraphQL Foundation, which is under governance of Linux Foundation. So like entire specification is open source. And so what are the features of GraphQL? Like the basic feature is the ability to determine what data you want to get on the client. So not like in REST where you have predefined endpoints with static payloads, let's say. In this case, it also returns JSON, but it is you, the developer, who defines what data you want to get in your client. There is only one endpoint where you combine all your data. That's why this is referred to as a graph. It has typing support, which works very well with typed front-end languages such as TypeScript. It's backend agnostic, which means you can use it with any technology. Use cases, yeah, basically like REST. This is a tool to build APIs. So the best use case is web applications that use modern front-end tools such as Next.js, React, yeah, and all those new cool front-end libraries. It works really great with TypeScript and all kinds of typed languages due to strong typing support. The best thing about using GraphQL is that you can generate front-end code from your schema. Yeah. You can also use federations. This is a concept where you can, in one graph, you can compose different APIs. So let's say you are building front-end application with some like front-end like JavaScript framework, but you want to fetch data from different services. Like you want to fetch data from e-commerce site, from CMS site, or from some other source. If those sources support GraphQL, you can put them into one gateway, one federation, and have access to all different APIs under one endpoint. Communication between microservices is also possible, but it's not that common use case. As I said, most popular usage of GraphQL is basically for front-end tools and for your front-end teams. There are two basic components of every GraphQL API. The first one is the schema. I'll show you actually a real example in a moment. Basically, a schema is a document. It's built with schema definition language. It's provided by the GraphQL specification, how to write it. Basically, it consists of simple scalar types such as string, integer, boolean, etc. And you can build your own custom types. So in this case, for example, I have a user type or a post, like in a blog post. So I can create my custom types to represent my use cases, my business domain that I need for my application. And this is also a place at the top, schema, query, and mutation, where you define all your queries. So in REST, that would be endpoints. And mutations in GraphQL are operations that you use to modify data on the server. So all kinds of operations where you create something, update something. In GraphQL, we call that mutation. So schema is the first part. This is where you define your operations. And the other part are resolvers. So resolvers are basically functions which tell the GraphQL engine what data to return when the engine is executing any query. So I think most of the frameworks follow this principle that you start with resolve underscore, this prefix, and then you put name of the field for which you want to resolve data. So in this case, I have a query user by ID, and this resolver, this is a Python function that would be run when the engine is executing this query. So I can put whatever I like in this function. I could put call to my database. I could run query to some other service, or perform all kinds of logic I need for my resolvers. So since we have a lot of time, I thought it will be interesting to show you some examples in case you haven't seen GraphQL in action. And actually, I'm running locally Ariadne framework, which we are going to talk about later. So yeah, I'm running here. This is a fast API application, very simple. And when I go to localhost / GraphQL, this is my API endpoint. This is access to entire API. And I think that every framework that I know provides this nice interface to play with your API. And here you will see some nice features of GraphQL. So basically, to start writing a query, I just can hit Control space and have auto-completion. So it will automatically show all the queries that are available in my API. This is a very simple example, so I have only like a bunch of queries. And yeah, and that's it. And this is how you actually call, in REST, that would be an endpoint like get users. Here it is a query called users. And here inside this, this structure, you define what fields you want to return to your client. So the benefit of this is that if you have a lot of data, or you have, I don't know, large JSON structures in your models, maybe you don't want to always return those structures to your front end because it will basically take more network bandwidth. So this is the way of fetching only data that you need. So usually, like this is used for developing this IDE. Normally, you would write those queries and execute them from your front-end library, from React, Next.js, and etc. And what else can we do here? So this is a user entity that I defined in my schema, but I can traverse the graph and go to the posts that the user created. So imagine that I'm building a blog, and I want to fetch users and posts of these users. And you basically go down deep in the structure, and this data, this is the graph functionality that you can traverse between different entities. In my database, user is like separate table, and posts are also separate tables. So this nesting will actually have to run another database query. So as you can see, we have auto-completion. We can traverse the data. We can pick data what we want. GraphQL also comes with like built-in documentation, where for each query I can like see what queries are available in my schema. I can write some short documentations. It can be even longer with some details like what permissions are required to get this field, etc. I can see what input arguments are required. So for example, if I want to return user by ID, then you can just get it from this documentation. I can see what fields are available in my user type. And as you can see, each field has a type. So, so the front end will exactly know what data to expect. Yeah. Also, the exclamation mark at the end means that this field is required. Some fields are optional, like this one, but this one has exclamation mark, so it will never be null. It will always be a string. So this is convenient for front end, as it knows what data to expect always. Yeah, so that's basically like the basics of GraphQL. So let's talk about frameworks now. There are two approaches to building GraphQL in general, schema first and code first. So schema was this document that you saw, which defines what operations you have in your API. And some frameworks follow the schema first approach, where you first write this contract, first write this document with schema definition, with all the fields, and you keep adding more fields as you build your product. And then you build resolvers for this schema in order to return data. So those little Python functions. So this is the first approach. And the other one, code first, is that you don't actually write the schema by yourself. You just write some Python classes, Python functions, you use some decorators and stuff like that. And the schema is generated on the fly. So this is what Strawberry does, for example. This is what Graphene does, another library. And I'll show you two examples of two libraries with those two different approaches. I don't have any opinion which one is better. It's like both approaches are good, I think, and libraries in both approaches are equally supporting all of the features that you need to write applications. So let's look at Python ecosystem. So first library I want to show you is Ariadne. It's, I would say, small library, lightweight, but very powerful. It doesn't come with all the features built in, like it doesn't have solution for authentication, for permissions. You have to add this yourself, but this is very lightweight framework and gives you a lot of flexibility. So it's a schema-first approach. It's asynchronous, so it works based on Starlet, which is an ASGI or ASGI framework. It supports asynchronous execution, so basically modern Python with async execution is possible with Ariadne. You can have real-time subscription queries where data is returned by WebSockets in real time. So all of those cool async features are supported by Ariadne. Yeah, and it also has extension module which lets you generate Python clients based on the Ariadne schema, which is also very nice. Yeah, and I have some slides about it, but I actually have very simple demo of this framework running. So I quickly show you how to define GraphQL API with this real example. So this is a very simple app. I hope you can, like, is it okay? The font, you can see it well? Okay. So this is very simple. It's actually Fast API app. So here I'm creating Fast API app, which has like one endpoint. And in here, I'm mounting the GraphQL API. So this object GraphQL comes from Ariadne. Ariadne ASGI import GraphQL. If we go there, we can see that this is an ASGI application, so it can be easily mounted and served in all kinds of frameworks. So this is one endpoint that I have in my API. So how it works. In order to serve the schema, I need to provide the schema object. So let's go there. And the schema object is providing the resolvers for my schema. So the schema is defined basically as a large string. In Python file, you could split it into multiple files as your schema grows larger. Usually, if the application is quite complex, this will become like this big file and you want to split it into multiple ones, smaller ones. Yeah, so this is basically a string in Python, as you can see. And here are all my fields definitions that I have available in my schema, like some hello query, users query, getting users by ID. Here are my operations to modify data, like create user or create post. And below are definitions of my custom types. So in this framework, you first create this definition, and then you create bindings in Python in order to resolve data for this schema. So in Ariadne, you need to first create a few objects. So for all queries you want to register, you basically import this query type class, create an instance of this query, and then you have two options. You can either just write those Python functions like this one, resolve hello, and use a decorator like this to bind it to the schema, or you can use this syntax query set field and manually pass the function that you want to run when the query is executed. When you gather all of those bindings, then you just pass them to this function make executable schema, and this is what is passed to the fast API endpoint. So basically, that's quite simple. And I have my resolvers split into two separate modules, one for posts, one for users. And yeah, and here are the resolvers to return all posts, like for my blog posts. It's just very simple. It's returning data from DB without any processing. Actually, in this example, I don't even have a DB. It's just a dummy database, structure in Python. Yeah, but that's how it works. And here is a resolver for a mutation. So if I want to create a new post, maybe let's see that. I write the keyword mutation, create post. In the input, I provide ID of my user. As you can see, some fields are required, so it will give me a warning that it cannot execute the mutation because it still lacks some fields that are required in the schema. And now the input is complete. And now I have to define what data I want to return if that mutation is executed. So I want to get error if there is any. So these are basically application errors, such as if you have some custom validations that you can return some errors here. But I want to get the ID of my new post, email of the user that created this post, the content and date of creation, right? So if I run this mutation, I got the result, right? So there is no error. Here is my new post and all the data that I asked for. And this is all handled by this simple resolver. Usually that would be a little bit more complex, but basically that's the idea how it works. Yeah. So these are resolvers running the app you saw on the example. And that's basically it. If it comes to Ariadne, as I said, it's quite lightweight. So if you want to support authentication, you need to figure out your own solutions. There are like libraries for that in Python. So you have full flexibility for that. And now let's talk about Graphene. So this is a different framework. It's actually the first one, I think, that was created in the Python ecosystem a few years ago. And I think it's inspired by Django. Like the style that you build the server is similar to how you build in Django, your models and etc. And this one is code first. So here we don't build this schema file that you saw, this large string with schema definitions. You just build the classes to represent your model. You build the Python functions, and the schema is actually generated on the fly. You don't even see it. It's just served by the framework. Yeah, so code-first approach. It has more rich ecosystem of libraries. It has integrations with Django, Flask, support for other databases. So in Django, you can easily generate models from your ORM. Also support for SQL Alchemy as well. So let's see how you actually define the queries in here. It's quite similar, but it's all based on classes in Graphene. So first you need to do is to import object type from Graphene, and to define all your queries in your API, you just build this query class, which needs to be passed to the schema object. So this is similar to Ariadne. You always have to build the schema object that is later connected to your URLs. And here, which is quite similar to Django, you just declaratively define fields that you want to have in your API. So in this case, I will have user query, which will have one argument ID. That will be the user ID. Here I'm passing user type, which is the type that I have defined somewhere in my code in a similar manner. And here I'm adding resolvers for those fields. So to return a user by ID, I just, so this function accepts these arguments. So the root will be, like this is a little difficult to understand at the beginning. So I'll show you the example. If you are running a query like this is top level. Yeah, so we are just starting to write a new query. The root is always null. There is no root object in this case, but if you are deep in the structure and you want to resolve the posts, for example, so I need to build resolver for my posts, then when I'm resolving this field, my root object is the user instance for which I'm returning my data. So this is how you can refer to like other objects in your schema. In this case, so this is the first argument, the root one, info will hold an info. Here is my custom type definition. In this case, I'm using Django, so based on Django, you can just import Django object type, and in the meta class, you pass reference to your model. And based on that, Graphene will generate the GraphQL type for you automatically. You can define what fields you want to take from the model, and resolvers for those fields will be added automatically. But you still have option to override them. You can always write custom resolver. So in this case, let's assume I have a user model, and I want to return credit card number for this user, but I want to first anonymize it, like display only last 4 digits of the credit card. So I can just add function, put my logic in here, and it will always go through this function when returning credit card number. Mutations may seem a little bit more complex, but actually it's also a simple class. You need to use the Graphene mutation class. Here at the top, you define response from your mutation. So in my case, this will be the user object, as this is a user create mutation. Also errors, if I want to return some errors to my front end, for example, that user with this email already exists, I could put those errors in this field. And for this resolver, you need to build this function called mutate. And also it gets the root object, info with the request information, and input, which gathers all the input fields for this mutation, which are defined here in arguments. So user create input is again another simple class which will hold all the fields that you need to have in order to create the user. And you put all your logic in the mutate function, so you can fetch data from a database, do some validation, save it, add some additional logic like sending activation email, and then you just return that, and this will go to the GraphQL response. Serving the schema is similar. You just import the, actually there is a mistake on this slide, as there should be schema passed to this view, but this is how you, the schema object, you tie it into this GraphQL view, and this is served as the GraphQL endpoint in our Django application. The same would work with Fast API and other frameworks as well. So we've seen some basics. Now let's talk about some common use cases that you would have in your applications. So authentication with GraphQL. The most common scenario is using JSON Web Tokens, just like in REST. So to achieve that, you need some mutation in order to authenticate the user. So in our case, it could be a token create mutation, which accepts email or password. And in the response, it will return the token. So you can build that yourself, or there are tools like Django GraphQL JWT, which does that for you. And when you get the token, you can just pass it as the header to your requests. It's possible with GraphQL. And then you will have authenticated users. If you want to have some permission system, then also you can build a solution based on decorators, for example. You could also pass that into resolvers. As I said, you have full flexibility about what you want to achieve in GraphQL in those resolvers. This library, Django GraphQL JWT, provides decorators like permission required. So you can just wrap the resolver with this decorator, and then, assuming that you have some permission system in your code, like there is a manage users permission that needs to be that the user needs to have in order to resolve this field, you can require it like this. And N+1 problem, that's also interesting and always worth mentioning when talking about GraphQL. As you saw, we can go quite deep with, that's the feature of the graph actually. So if we have query like this, we fetch users, then we fetch posts of these users, but then we want to fetch author of that post. And then we can go even further and keep getting posts of that user. So we can go deep and deep and deep, and this will get really complex, and still our server has to handle it somehow and run those database queries. So this, as I said, if these are different entities in your database, posts and users, you will have to somehow manage it. So in the naive, simple solution, if you don't have any optimizations in place, assume I have 50 posts and each one has a user. When I run this query, I would run in my SQL query to get the blog posts, all the blog posts, and then for each one, it would generate another SQL query for each of those users, which is of course easy. So instead of executing, when the engine is executing those queries, like this one, it won't run the query each time it resolves the user, but it will actually make it lazy. So it will first see what user IDs I need to resolve, and then you fetch them all at once from the database. And this is maybe a little bit uncommon for Python. It's using promises like in JavaScript, but it's actually very useful if you want to optimize your GraphQL servers. Here is example implementation of a data loader. So basically, when using these data loaders, you are never running ORM queries in your resolvers like here. You always use data loaders. So this is basically a query to ORM which fetches all the user IDs that were seen in the GraphQL query in only one database query. Versioning. Yeah, by design, there is no versioning in GraphQL. Like in REST, you have version 1, version 2, and etc. Instead, in GraphQL, you add fields in an incremental manner, and you keep evolving the schema basically by adding new stuff and not removing stuff to not break clients. But what you can do is you can mark a field as deprecated, as in this example. This is also a useful feature of GraphQL called directives, which mean that you can add some additional logic to a field in your schema by using this syntax. And deprecated, this directive is built in actually. So whenever you add this, deprecated, this field won't be visible in the schema editor. You can still fetch it, but you will get a warning that you are using field that is outdated, and maybe there is some other one. It's a good practice to add message, use user by ID instead. So if I'm using this, I will get the warning, I should be using this field. So this is how you evolve the schema. Yeah, that's all I have for you. And these are some resources that I used and recommend. Two books that I recommend. The first one is more about basics, and the other one by GitHub developer who was working on GitHub GraphQL API. So this is for more complex use cases. If you want to check our API that we do, you can check Sailor GraphQL API. This is a link to the simple Ariadne demo that I showed today and links to the libraries. And that's all I had for you. I don't know if we have time for questions. I think we are. One question? Yeah, okay. If no questions, you can just talk to me. I'll be around here if you are curious about GraphQL or want to know anything about the stuff I talked about. So thank you so much.
Thank you, Marcin, for your insightful presentation. If there are any questions, maybe you can discuss it right to him outside the session. Let's give a round of applause again to our speaker for today.
Thank you. Thank you.